Hi, everybody, and welcome to TGCS. My name is Tim Gallagher, and today we're going to be discussing AP Computer Science A Topic 4.5, Implementing Array Algorithms. And in the second of three videos, we'll develop code for standard and original algorithms that involve arrays and determine the result of these algorithms. Specifically, we're going to look at these three algorithms. First, determine the minimum or maximum value of all the elements in an array. Next, access all consecutive pairs of elements in an array. And finally, determine the presence or absence of duplicate elements in the array. Okay. Whenever we develop array algorithms, we want to make sure that we figure out first what we need to do, what our constraints might be, and so on. So here are some of the questions that we may want to ask and answer before we write any code. What's our goal? Do we need to get a value or location? What type of results do we want? What type of values are in the array? Are they objects? Are they primitive types? And how can we compare, accumulate, or check what are the attributes of these elements? And finally, do we need to traverse the entire array? Or can we maybe halt early before traversing everything? All right, let's look at our first algorithm. Finding the maximum or minimum value. So here we have this array of integers, and we want to determine how we can find our maximum value within the entire array. Now, we're going to have to visit each location, so we're not going to be able to halt early. And since we're searching for a maximum value, we're going to need a variable to hold that value. We'll call it max. All right, we'll start with the first value of the array as our max because that's the first one that we've seen. Then we're going to traverse the entire array, comparing each value to max to see if it's greater. Now, these are primitive types, so we know we can just use the greater than logical operator. We'll traverse to 12. 12 is not greater than 20, so we're not going to do anything. 8, also not greater than 20. 32 is greater than our current max. So now max becomes 32. 32 is our new maximum value. 24, not greater than. 42 is greater than. So now you can see 42 becomes our new max. And then the very next value, 60, is another larger value, larger than 42. So now 60 is our new max. 55 isn't larger than 60, neither is 3, and then neither is 21. So in this array, we've determined that 60 is our maximum value. All right, let's look at how we might write this code. So here we have a static method called findMax, and it takes in an array of integers called values. It also returns an int. That's going to be the maximum value. So what do we do first? If you like, feel free to pause this video and take a go at writing this method before we go over the code together. All right, let's do this. So we're going to initialize max and declare it and initialize it to be the first value in my array, values bracket 0, because again, that's the first value that we've seen. Now we need to traverse the array searching for values that are larger than max. So here's my for loop. I'm going to use a traditional for loop, but I could have used an enhanced for loop here as well, since we're not modifying the array and we don't need the index numbers. But notice that I'm starting the array at 1. Well, that's because I've already saved the value in position 0 as my max. I could start at 0 here, and it really wouldn't affect it. I would just be comparing it against itself in that first comparison. But what is our comparison now that we're going to do? Well, if values bracket I is greater than max, if we ever find an element in values that is greater than our current max, then that becomes my new max value. So max equals values bracket I. Are we finished? Can I return max? Not yet. I've got to finish searching the entire loop because we don't want to return max until after the loop is finished. That way we don't miss comparing any other possible maximum values that might exist out there. So that's our algorithm for finding the maximum value. Now, here's a question for you. How would this look different if we wanted to find the minimum value of the 2D array? Well, it would look something like this. It looks very similar. Mostly the changes involve comments and the variable names, but the key algorithmic difference is right here. Now we're going to look for a value that is less than min rather than greater than like we had before. All right, let's explore another algorithm. Let's implement an algorithm that involves accessing consecutive pairs of elements in our array. So this method accepts a value of an array of integers called values, and we want to determine if the consecutive values are increasing as we traverse through the array. So let's discuss the steps for this algorithm first, and then we'll implement the algorithm. So what do we want to do? We want to traverse the array, right? And then if we want to verify that a value is less than the next one. If it is, well, we don't need to do anything yet. We just need to go to the next value and keep checking that that value is less than the one after that. However, we keep looping until we get to the end of our array. But if at any point we find a value that is not less than the one after it, well, then we want to return false immediately because the values in the array are not increasing. After we traverse the entire array without returning false, we're going to go ahead and return true, because that means if we've never returned false, then all of the values in my array must be increasing. All right, let's take these comments and let's take these this algorithm and put them into comments as we write our code. If you like, take a shot on your own and pause the video here first. All right, let's try this. So one strategy for implementing an algorithm would be to change the steps into comments, and that can help direct how we want to write our code. So we know we need to traverse the array first. So let's have a for loop. Again, I'll use a traditional for loop here, and I'm going to have to because I need to utilize the index numbers to access consecutive pairs. So if a value is not less than the one after it, I want to check to see if a value is less than the one after it or not. So in this case, I've got a Boolean expression here in an if statement. So if values bracket I is less than values I plus one, if that's the case, then I'm good, right? This compares a value of the array to the value in the next location in the array. Using I and I plus one gives us our consecutive values. Now, we want to return false if this is not true. So what do I do to check to see if this is not the case? I'm going to put right there an exclamation point before a Boolean expression. That indicates that if I found a value that is not less than the one after it, that's when I want to return false immediately. After the loop is completed, I'm going to return true if we're still there, because that means we never found values that were not increasing. All right. But if you are an eagle-eyed viewer, you may have noticed that there's one problem we still have to fix here. Can you spot the error? Well, with our loop going up to but not including values.length, having I and I plus one, well, that's going to throw us out of bounds past the last element. What we need to do is add a -1 after our values.length to prevent us from going out of bounds on our loop. Now, that's an important detail to remember when writing an algorithm that involves evaluating consecutive elements of an array. All right, that's our completed algorithm. Let's try one more. So here we want to determine if there are any duplicate values within a given array. This method returns true if there are duplicates in the parameter array called values, false otherwise. Again, let's discuss the algorithm first. So what are the steps that we'll take to find the existence of any duplicates? Well, we're going to traverse the array. Now, to look for duplicates, it would be easiest to check all of the elements that are contained in the location after the current element. Well, how do we do that? We're going to need another loop. We're going to have to traverse the array starting one after the current element, again, with another loop. So if we ever find any two values that are the same, then we're immediately going to return true because we found a duplicate. However, if we traverse the entire array without returning true, well, then we're going to return false because that means we didn't find any duplicates. All right, let's put these comments, let's put this algorithm into comments and write our code. So here's our code. If you want to take a minute and pause here and give this a shot, feel free, and we'll come back in just a moment. Okay, let's implement this algorithm. So first, we know we're going to need to traverse the array. So I've got a regular for loop, I equals 0, I less than values.length, I plus plus. And then I went ahead and stored values bracket I into a variable called current, just so I can keep that straight, knowing that current is the thing that I'm going to compare to all the other values in the array. Now, we need to traverse the same array, but we have to start after our current element. So let's have another loop, but this one is going to start after the current value of I. So notice we have int a equals I plus 1. This allows us to have an index for all subsequent elements in our array. Now we'll continue the loop all the way to the end of the array, again using the values.length. Now we want to check to see if our current value, which is values I, is ever equal to 21 to any value after it, values bracket A, as we loop through all of the current elements after current. Now, if we ever find a match, what does that mean? We should immediately return true because it only takes one pair of duplicate values to indicate that there are duplicates in this array. Then, after the loops have completed, we're going to return false because if we're still there, that means we never found any duplicate values. And that's our algorithm for determining whether or not there are any duplicates in an array. How'd you do? All right. So today we developed code for some standard and original algorithms that involve arrays and determine the result of those algorithms. Specifically, we found the maximum value of an array. We developed an algorithm that involved comparing consecutive elements of an array, and we determined the presence of duplicate elements in an array. We'll do even more algorithms in our next videos. Until then, that's it for this video. Thanks for joining us here. Don't forget to like this video, subscribe to my channel, and we'll see you next time. Take care.